Hi, everybody. My name's Murray, and I'm here to talk about AMOS. It stands for Aquatic Mini Observation System. If any of you were here previously at the for the meetup in January, I did a presentation then as well. But I'll do a bit of a recap here, just to bring you up to speed on what AMOS is and what it does and that sort of thing. So it's basically an autonomous solar-powered airboat, and it navigates around to different GPS locations and collects water quality data at those locations, and then transmits or stores it as necessary. So the idea for this sort of came about 2.5 years ago. Locally, we had some problems with water quality at one of our beaches, problems with E. coli in the water. And to analyze the water, it was typically kind of difficult to pay someone to go out and collect the water samples and bring it back to the lab, do the analysis. And it would take usually a couple days before you would find out what the water quality was. And even then, you'd only get it at certain locations. So I thought there must be some better way of doing this automatically. And that kind of gave birth to the idea of AMOS, having a water quality system that navigates itself around in the water and analyzes the water in situ and collects the data, stores and transmits it in real time. So you get sort of a real-time idea of how your water is doing. The original prototype in 2018 was constructed from a beer cooler. You can buy this beer cooler from Canoeler Products, I think it is. And it's supposed to be able to hold 50 cans of beer. I only had about maybe 5 pounds of electronics or something inside of it, including the battery. But it worked okay. You can see it has a propeller here down on the image on the grass. The propellers worked pretty well most of the time. They were quite powerful. They're from Blue Robotics. It's called the T200. But the one drawback of using the water propellers was that they would get fetched up on grass or seaweed. And as soon as that happened, it would stop working. I mean, sometimes even having just a bit of garbage, like a candy wrapper in the water or a rock getting into the propeller would be enough to seize it up and stop it, which really isn't acceptable if it's an autonomous vehicle. So that gave birth to the idea of the surfboard. That was last year's prototype, and the prototype that I was presenting at the last time in January. The biggest difference on this one, apart from the obvious length and shape difference, is the air propeller. It's basically just a drone propeller mounted on the back end, and it has just a simple 3D printed mast that's connected to a small waterproof servo motor that's mounted on top of the rear battery enclosure. And this worked quite well. Because it was much more hydrodynamic than the beer cooler, it didn't really require a whole lot of thrust from the air propeller. Just having that 1 pound of thrust from the air propeller was enough to move the boat forward at about 4 or 5 kilometers per hour usually, if you're on calm water without much wind. So that was pretty good. This year, though, I decided it'd be better if I could shorten the boat up a little bit. Having something like the 8-foot surfboard is a little bit difficult to get in and out of the car and in and out of the house, and I can't imagine how much it would cost to ship that. So I instead this time used 2 foam pontoons, so it's effectively now a catamaran, and joined them together with 4 aluminum plates, 2 large ones at either end and 2 smaller plates in the middle. And it uses a lot of the same electronics and equipment that was on the previous prototypes, but it's a different shape and a different solar panel as well. I found that I really needed to have a solar panel has a good waterproof rating. The previous ones I was using tended to fail after 6 or 7 months. But this one I've been using for over a year now. It's from Renogy, and it's 100-watt solar panel. It's flexible, and yeah, it works really well. Here's a little video of the latest catamaran prototype in action. This was recorded by me in my kayak on July 4th, I think. It's just in downtown Fredericton here, Fredericton, New Brunswick in Canada, where I live. And it's just coming up to a walking bridge there in the left part of the screen. There was a bit of wind that day and some waves. Probably about the maximum wind speed that it could tolerate would be, like, if it's a 20-kilometer headwind, that would probably be a bit too much for it. But for anything less than that, it still works pretty well. So now I guess at this point I'll talk about some of the improvements that I made in the electronics and software and so on. One of the first things I was able to do was to clean up this messy jumble of wires that I was using last year. The new version of the wireless transceiver has basically all the same parts. It's just organized in a much neater fashion with a printed circuit board, and it still uses the same Pelican 1010 case. It's a nice waterproof case, and it works pretty well. It's got the wireless transceivers from Synapse. Has a range with I think a 3 dB antenna of about 500 meters, and has a FTDI breakout board for connecting it up through a USB cable to a PC, or you can use the Bluetooth interface if you have a smartphone. So that all seems to work pretty well, and there's sort of a companion board without the Bluetooth mounted inside of AMOS that gets paired up with this one. Excuse me. Over a number of months in the winter when I wasn't out testing, I improved a lot of the software, desktop software primarily for using with AMOS. I was fortunate in March to get involved with the Esri startup program, and that enabled me to make use of their .NET SDK. So that's like for using ArcGIS within your own applications. And they have some really nice maps and so on, and a nice way of presenting your data in a map-based interface. And it makes it easy too for defining what routes AMOS will follow. And so I'll just sort of show some examples of that. Here's a screenshot of the desktop software. The boat itself is indicated by the yellow outline there. I think that's probably my backyard. There's no actual water there. And this dialog interface here is for specifying which script is running on the boat. And you can step forward and backwards through that script and load up different scripts, or basically stop the script, do whatever you want. And there's other dialog interfaces for changing which sensors you want to appear and doing that sort of thing. In the top right corner, you can control the boat manually if you want to, just using the direction key. Another thing you can do in the software is define safe locations where the boat can go to recharge its solar panel. So those are indicated with the red plus signs there on the map. And whenever the boat is on its route, the yellow route there, and it detects that its battery is starting to get low, it would go to whatever the closest plus sign is to recharge its solar panel for an hour.
What is special about those locations?
Generally, I mean, you'd define them to be, or you'd want them to be a location that, for example, on the north shore where you're going to see more sun exposure. If it's sheltered or that sort of thing, where the boat hopefully won't drift away too much if it's just sitting there. The boat can save a log file, or does always save a text log file in it, and you can play back this log file later on in the software to see exactly where the boat went and what its various voltage and temperature and heading parameters were at any given point in time. And you can also look at the data, which also is in a text comma delimited format. And the data is just indicated by different colors at each location. In this example, it's just temperature data, only between 11.5 and 12 degrees. But each sort of temperature has its own color, and you can turn on the interpolation option there to look at an interpolated view of all the data, and basically just using a sort of least squares method of interpolation there for getting all those interpolated points between the real data points. One thing I wanted to do was improve the magnetometer calibration. Some of you might remember from the previous presentation I did, the calibration I had before was kind of crude. I would just basically hold the electronic compass module by hand and rotate it around in as many different orientations as I could think of. And while it was doing that for like 5 or 10 minutes of this rotations, I'd record the data and then look at the minima and maxima for each sensor axis and use those to figure out what the offsets and gains were. But this method is a lot easier. It's, I think, similar to what a lot of cars and other vehicles do for calibrating their compasses. Basically just move the device around in a slow circle, and by collecting like the X and data in the X and Y plane, you can figure out what the center of that circle is and what the radius is, and those correspond to your sensor offsets and your sensor gains. I have some software there on my GitHub page if you want to check it out for how it does that. It uses an iterative technique to figure out exactly sort of what the center of that circle is. So you don't really even need to have be going at a uniform speed to get good accurate data. It works as long as you have some sampling of points around the circle. In terms of accuracy, I didn't really find a huge improvement in accuracy. It was still maybe a few degrees better, but so long as you can get about plus minus 10 degrees of heading accuracy, that's really good enough for most of the navigation needs of AMOS. Its GPS accuracy is about plus or minus 10 meters. So, and I generally require getting within about 20 meters of a point to get a sample. So it's good enough, I guess, for that. For demonstration purposes, I wanted to have some way of getting a parameter that would change quite a bit depending on what location you're on in the water, and depth seemed to be a good one to pick there. To do this easily and as inexpensively as possible, I chose a fish finder. For measuring depth, you can really get into some pretty high-end equipment with side scan sonar and all that kind of stuff. But for the fish finder I was using anyway, it just had a simple down beam transducer. So it just shoots an ultrasonic beam down from the transducer you can see in the picture there, and shoots it down to the bottom, measures the reflected signal off the bottom, and gets your depth distance that way. And the model I selected had a nice digital output, NMEA0183 depth output. So that made it easy to integrate into the AMOS program running on the Raspberry Pi computer. You can see the RS-232 circuit board I was using there. I had a nice FTDI RS-232 cable for that, but turned out I didn't actually have the proper DB9 connector for it, so I ended up ripping the cable apart and soldering directly to the circuit board. Probably not recommended, but it worked okay. And I was able to get all the data, the depth and temperature data at an update rate of about once per second. The serial data stream was 4,800 bits per second, and it would have a number of symbols and so forth coming back, but I was just really interested in the temperature and depth stuff. You can see here on the software, there's the depth readings that I collected one day. This is in Kelly's Creek Basin, and in the basin area here, out in the middle of the water, it's around 30 meters of depth. So that corresponds to the red colors, and then the shallower stuff is in blue and purple there. And it looks kind of nice too when you interpolate it. So just a bit of a different view of the data there. One of the mechanical improvements I made this past year was for the Raspberry Pi visual camera. Initially, I had basically just a 2 millimeter thick plexiglass window that was bolted to a 3D printed enclosure. And it worked okay, but it was kind of time consuming and difficult to squeeze all of the nuts and bolts in there and get it on just perfectly balanced. And it was kind of a bit of a nuisance to put on and install. But after a while, I finally came up with a sort of screw-on cap that was much simpler and faster to install. And I made a little instructable for it too, if you're curious about what 3D printing parts and steps were taken to produce that. Initially, I had wanted to collect some data for blue-green algae. That's kind of a trendy thing that people are concerned about these days for water quality. But it turned out that the probes for measuring blue-green algae also require that you measure temperature and conductivity at the same time. And to do that, you typically want to have a multi-probe. And the multi-probes that are commercially available are fairly expensive. So I didn't decide to go that route and decided instead to measure something a bit simpler, dissolved oxygen in this case. And I got a kit from Atlas Scientific. The one I got was pretty good. It had both a serial and an I2C interface. I decided to use the I2C just because there were already 4 devices connected to the Pi on the I2C bus. So it was easy to hook up that way. And it offered a simple 1-point calibration that you can do just with the probe hanging in the air. So that was easy too. You can also do a 2-point calibration, but so far I haven't tried that one yet. And this is a galvanic probe, so it uses an electrolyte solution within the probe and basically a very thin membrane on the end of the probe. And so by measuring when oxygen molecules in the water basically get transmitted through the thin membrane and produce a current and a voltage within the probe. The voltage is measured and you get your dissolved oxygen reading that way. I found it worked pretty well. The only drawback, I think, was that the membrane, it's about probably the thickness of a contact lens. It would tend to get nicked if you're in really shallow water and dragging the end of the probe on a sandy bottom or rocks and that sort of thing. So that was a bit of a problem. And of course, when there's any sort of nick in this membrane, you lose your electrolyte solution pretty quickly and it goes out of calibration. So I learned to kind of stick to the middle of the river for dissolved oxygen testing. And you can see some example data that I collected in the river there. It's in this case, all the points are pretty close to one another, between 9.15 and 9.9 milligrams per liter. And I'd go out usually on the weekends with the boat and do some testing in the river and in a couple different locations. And you could see sort of from the mid to end July to the middle of August, the dissolved oxygen levels dropped with the corresponding increase in the water temperature. The water temperature is actually fairly hot in the middle of August. It was around 25 or 26 degrees Celsius at the surface of the water where I was measuring. So And then in September, things cooled off again, of course, and dissolved oxygen went back up. Now I guess I'll talk about some of the problems that I've encountered with AMOS lately. Some of them were overcome, and some of them still working on. One of the problems I noticed early on in August with all the hot weather and humidity was the adhesive I had used to bond the aluminum panels to the foam pontoons had kind of, I don't know if it dissolved or just delaminated. And so basically the boat was falling apart, and decided to switch instead to JB Weld marine epoxy. And that stuff was pretty strong. It's rated for 4,000 PSI and rated for, a marine environment. And it took, I think, 24 hours to cure, but it so far anyway, it's held up really well, and it's held the boat together. So that's it's kind of expensive, but I guess probably necessary if you've got critical things that you don't want to come unglued in humid weather. The LIDAR module I've been using, the LIDAR Lite 3, I've been using it for a little over a year, and quite happy with it. Has an I2C interface as well, and yeah, it's worked really well. It's rated for object detection, I think up to 40 meters. I found it worked well up to about 20 meters. Possibly you could get up to 40 meters in some cases if the obstacles are fairly reflective. Just a couple issues that really pop up, I think, with any LIDAR module, are that it can give you a false positive if you're in foggy weather. That can be a problem, especially at this time of year when the water temperature is a fair bit warmer than the air temperature. You tend to get foggy weather in the mornings. And so the laser light just reflects off the water droplets, and the software thinks it's seeing obstacles everywhere. So I usually turn off the LIDAR if I know it's going to be foggy that day. Another thing that can kind of, or that I guess the LIDAR doesn't notice, are narrow obstacles. So if you've got like a narrow stick jutting out of the water, you can still, the boat can still get fetched up on that, and it won't, basically just the LIDAR laser light misses the stick and doesn't see it at all. So I'm not sure what to do about that yet. I mean, it could possibly be a visual thing you could do with a visual camera to pick up on something like that. I'm not sure. I've done some visual object detection about 2 years ago, and it's kind of tricky stuff. There's reflections in the water and other things that can kind of fool your detection algorithms, but there might be something there that you could still do for a certain class of narrow obstacles, maybe. And I don't know if you can see it or not, but in the bottom left corner here, there's a small can of beer on the solar panel of AMOS. And this was something that a fellow was put on top of it. He was out boating with his girlfriend or wife that day. And he was quite impressed that AMOS came up to them with him a few feet away and then stopped, turned direction, and went away. So he was pretty impressed by that. So the LIDAR was working well that day. Another issue I ran into again in August when the hot weather was with the electronic speed controller, ESC, overheating. The manufacturer of the controller said that it has a shutdown feature at 110 degrees. It'll shut down to 50% power. And I was able to see that at various times in August when the boat was out in the water. It would suddenly go down to half speed. And I figured, well, maybe why not put the speed controller directly behind the propeller to use the airflow of that to cool it off. Seemed like a pretty simple solution because, excuse me, the speed controller was in the battery box at the time, so it wasn't really getting any airflow at all in there. So I thought that'd be an easy fix to put it behind the propeller, but turned out it wasn't. I needed a longer cable to do that, about a foot longer or so, and by adding that extra cable length, it made the speed controller stop working at high speed. So that was no good. And after a lot of debugging and kind of troubleshooting and looking on the internet, eventually realized that the extra length of cable I had added to the speed controller had added inductance, and that was causing voltage spiking to occur, which was throwing off the speed controller. So by adding a number of capacitors between the power supply and ground to the speed controller, that was able to solve that problem. But I eventually, as I did more testing, realized that there were some I2C issues on the I2C bus that had sort of crept in somehow. I wasn't sure that happened, if I had messed up the wiring or what had happened there. So after a few days more debugging and scratching my head, looking on the internet and so forth, eventually realized that my pull-ups on the I2C bus were for 5 volts, were connected to 5 volts when they should have been, of course, 3.3 volts for the Raspberry Pi. So it's kind of surprising how well it had worked with the 5 volt pull-ups. But yeah, putting them on 3.3 volts fixed the fixed the I2C issues that I was having. And then again, having the speed controller outside once the weather cooled off here in September and October was no good, because then the battery got too cold. And as you probably know, if you've tried to use your phone outdoors for any length of time in cold weather, it tends not to maintain its charge or deliver as much charge. So I found I had to put the speed controller back within the battery box at that point to keep things warm in there. So I think in future prototypes or versions of the robot, what I'll probably do is instead of hard soldering everything, use banana plugs or something like that, so I can easily transition the speed controller out of the box or in the box, depending on what the surrounding temperature is. Sort of a recent challenge someone gave me. He was wondering if it'd be possible for AMOS to go across a river where there's a current, so move perpendicular to the current in a straight line and stay within that straight line to within plus or minus 15 centimeters. And of course I said, no, we can't do that. That's impossible. But I thought, well, I'll try it and see how close it can come to that. The first day that I tried it, the St. John River was had quite a lot of flow. We had about, I think, 40 millimeters of rain the night before, and AMOS got pulled down the river, you know, as it came out into the middle of the river. The current was just way too strong. And at one point, because the speed controller was outside the box, the battery got cold or whatever and didn't have enough charge, so the software shut it down, and it drifted about 400 meters down the river before I was able to catch up to it in the kayak and then pull it along the eastern bank for a while and then restarted it. And it was able to make it along a little ways and then again got pulled down by the current. So I moved it the following weekend to a more secluded spot. There's still a little bit of current. In this location, it was going from east to west. And you can see here for the 500-meter crossing, it stayed kind of close to the line, is probably within 20 or 30 meters of the straight line there. So definitely not plus minus 15 centimeters. I don't know if that would ever be possible in an autonomous boat, but I think there's definitely some improvements that could still be made in the software for improving on how closely it follows its course, and possibly using better equipment like better GPS or even survey level GPS if you really wanted to go for it, I guess. But yeah. So in terms of future work for AMOS, I'd like to investigate sort of methods for discrete sample collection. So far, all I've been doing is sort of probe-based stuff over the side of the boat at measuring sort of surface conditions of the water. So I'd like to have some technique, I guess, of lowering a vessel over the side of the boat to a predetermined depth and then opening a valve electronically and then closing the valve and then bringing up your water sample. So it'd be pretty cool to be able to do that. I think for say 6 or 8 200 ml bottles, that'd be kind of neat to bring those back to shore and look at your water in the lab. You can do sort of more advanced analysis that way. The thing I'm working on right now is making a wooden mold. I'd like to be able to construct the hull of the boat much more quickly than I had on previous prototypes. The previous ones used that sort of pink construction insulation foam, and it wasn't that hard to work with, just kind of time consuming. And if you had a 2-part foam that you just mix together and pour into a mold, that would, I guess, theoretically go a lot faster. I guess we'll see. And I'd like to be able to embed the electronics also within that mold, and hopefully the electronics boxes won't crack or anything when the foam expands. But I guess we'll find out. And so yeah, I'd like to make the boat look better and do more testing, and probably find some other things to work on in the future as well. If you're interested, got some links for more information here, and just a final picture of some geo-writing that AMOS did one day. A friend of mine asked if it'd be possible to do that, and so I gave it a try one day. And yeah, I guess that's it for my presentation. So yeah, if anyone has any questions.
It's a very colorful picture. I guess that's the depth as well, isn't it?
Yeah, that's actually depth data that I was measuring. So it's the same thing. The red corresponds to deeper water, and the greens and blues are the more shallow water.
And do you have a plan to use the depth in your in your control algorithm at all? Sort of see if you're getting too shallow, for example. And
no, I mean, I hadn't really considered that much, but that is a good idea. Like for objects, or obstacle avoidance, I guess would be to use that information. I guess you wouldn't always be guaranteed not to have an obstacle, but it's definitely more likely in deeper water that you're not going to have an obstacle.
Yeah.
Yeah.
Have you heard any from governments or anything like that that's sort of interested in buying one of these, or how's that side of things going?
I mean, I've been starting to talk to a fair number of people. No one's really bought it. No one's bought anything yet, but there are a few people that are interested, and they think it might be suitable for sort of monitoring of lakes and rivers on a long-term basis, perhaps. So it's encouraging enough to keep going with it anyway.
Yeah, it is very cool. I like how it goes somewhere to charge itself up and things like that. It's very useful little feature, isn't it?
Yeah, it's kind of necessary to have a safe way of recharging it. I did more work on that last year, and it was tricky to find locations where the boat won't sort of get either fetched up on the beach or just blown away by the wind to a different location. So one thing I spent some time on this past year was trying to build like an automated anchor system, and never really got anything very satisfactory from that, but that might be an avenue to explore in the future, as well as sort of
Murray, have you
some means
ever
of
had
anchoring
any malicious tampering?
Sorry, any tampering?
Malicious tampering?
Well, aside from his beer can.
No. I mean, well, there's one time someone in a motorboat kind of tried to swamp it, and they didn't. But no, there, at least not to my knowledge, there's never been anyone that tampered with it. On one of the versions I had operating by itself last year, I wrote like a little sheet on it that said, please don't interfere. This is doing scientific work or something like that. And here's a link to the website. And I don't know, in Canada, at least, that's been good enough. We're typically honest here.
So does it have an SOS feature so that if you get stuck, it calls you and you can go and rescue?
Yeah, kind of something like that. Yeah, there's an email feature or a text feature. If the leak sensors inside it see any water, it'll email or text you right away. And same thing too. If the battery's low, it'll send you a message about that.
Cool. Superb.
You mentioned maybe using banana plugs.
Mhm.
If you haven't already, I'd take a look at the Speak-On twist connectors because they're waterproof.
What is it? SpeedCon?
Yes,
Yes, and-
SPEAKON. It's all
And
one
Neutrik
word.
NL4.
Oh, okay.
But they also make XLR Canon from connectors, which might, because you don't need the volts that you could get through you're not shoving 20 amps, which you can do with an NL4. So you might be better off with an XLR connector, but something from Neutrik would make it weatherproof and fast.
Oh, cool. Well, thank you.
So I guess you're pretty happy with how the craft itself performs, right? So the catamaran was the right way to go, do you think, or is it?
Yeah, I think so. It gives it a bit more lateral stability. In the next one I'm doing, it's kind of going to be a bit of a hybrid between the catamaran and the surfboard, but it'll still hopefully have the same lateral stability of the catamaran.
And you don't want to add a center board or whatever it's called. I forget what it's called now in the sailing world. Skeg.
Yeah, I don't know what it's called either. But yeah, that's essentially what it's going to have is some centerpieces, both for situating the electronics box and just for holding the thing together. So I'd like to try and avoid the aluminum panels if I can, because they add a bit of weight to it, but we'll see if it's strong enough or not. I don't know if it'd be strong enough without the aluminum panels there.
Cool.
On one of your pictures, you've got a chicken wire cage around the propeller. What was that for?
Just for protecting the propeller and those fingers out of it.
Right.
Yeah. It adds a bit of drag if it's windy out, but it's kind of a nice thing to have, especially if you're going to be near overhanging branches and things like that to keep the propeller from getting tangled up in those.
Yeah.
When you're sending email messages, what's the wireless link? Is it just Wi-Fi, or do you have something longer range?
Yeah. Well, if it's I've got a USB hotspot thing, so that gives you an internet connection. So it connects over Wi-Fi to this hotspot. The hotspot's just within the battery box itself, and so it gives you basically access to the internet.
Mm-hmm. Yeah, I just wonder if you're going to use something like AIS to report your position as well.
No, I haven't used that. No. But I mean, within the email message that I get, it gives you the latitude and longitude of its current position and whatever the problem was, whether it's a voltage problem or a leak problem.
Do I remember you mentioning having a GSM link in your last talk?
No, I don't know.
Oh, sorry, my mistake.
No, it's okay. What is GSM link? I'm not sure.
Well, basically a phone link, because Wi-Fi gets you to the battery box, and from there, I guess you might have a phone link or not.
Oh no, the USB hotspot thing gives you basically a cell connection, so that connects to your local cell tower, and then
That's the same thing.
Oh, okay.
Different words. That's different words for the same thing, I think.
Okay. Yeah. That's effectively what it's doing then, I guess.
Cool. Any other questions?
I'm not sure who raised it. The AIS facility, would ships or other marine craft, obviously then they would have visibility of it. I guess on the positive side, that would mean that people would then potentially stay away. Or maybe on the negative, I mean, I'm sure in Canada it doesn't happen, but that would attract attention, and maybe you might be able to follow it disappearing off down the motorway.
Probably depends on the uptake of AIS. I mean, in European waters now, every small boat's got it, so you're just one in a crowd. It's not going to distinguish you. If it's rare, then yeah, you're going to be identifiable.
Okay, so no other questions. We'll take a break there.